Hi, here's our first example problem of a angled force situation. Okay, so we have a box that's being pulled by a force of 30 newtons at a 30-degree angle that's moving at a constant speed. So I want to know what is the normal force and what is the coefficient of friction. So again, I'm going to draw a free body diagram. So this time it is on horizontal ground. Okay, and we are now being pulled by an applied force at an angle of 30 degrees with a magnitude of 30 newtons. Of course, we still have the force of gravity pulling down on it. Normal force is still going up, perpendicular to the ground, and there is still friction because they're asking us to solve for the coefficient of friction. Okay? Now, something else that's key here is that it's moving at a constant speed, so that means that my acceleration, again, I'll put it off to the side, is equal to 0. Um, now, I did forget to mention that the mass of this box, I'll just put it up here, is equal to 10 kilograms. So I'll put that up here. I forgot to put that in. So there's my mass. Okay. So I am going to try to solve for normal force. So normal force, I really don't have an equation for normal force. So the only thing I really have is Newton's second law, some of the forces. Okay. Now, in this case, normal force is vertical, so I'm going to look at some of the vertical forces. All right. And that's equal to, well, vertically, it's not, this box is not accelerating vertically, so that means that uh, that this is all going to be equal to 0, and that's because it's not accelerating vertically. So now, when we do the sum of the forces, we have to look at, well, the forces are acting vertically. Now we have the force of gravity going down, normal force going up, but we also have components of the applied force. So this is my applied force, that 30 newtons. This is my FAX. This is my FAY. Okay, so I am going to have the normal force going up for my vertical force. I have the applied vertical force also going up. Okay, it's being pulled upward, and it's being pulled upward. And then the force of gravity is going against those two, so I'm going to make that negative, and the sum of those are going to be equal to 0. All right, so now that I have this figured out, now I can also solve, see what I also need to solve for normal force. So I can figure out force of gravity easily enough. It's just weight. So let me just do that down here. Weight is mg. Mass is 10 kilograms. And g is, of course, 9.81 meters per second squared. And so I have 10 times 9.81, that's 98.1 newtons. Okay, so there's my weight. I also have FAY. So FAY is right, this is opposite of the 30-degree angle. So, and I have the hypotenuse, so that means opposite hypotenuse, I'm going to use sine. So I have sine of theta is equal to opposite, which is my FAY, over my hypotenuse, which is my FA, which is 30 newtons. So now I can just kind of plug in my numbers. So I have sine of 30 degrees is equal to FAY, my unknown, divided by the applied force, which is my 30 newtons. So I multiply both sides by 30 to get FAY by itself. And so I have sine of 30, which is 1/2 times 30, which gives me 15 newtons. So there's my FAY. I know my force of gravity or my weight. So now I can just kind of plug everything in. So sum of the forces vertically, and that's equal to Fn, which is what I'm solving for, plus FAY, which is 15 newtons, minus F of g, or weight, which is 98.1 newtons, and all that's equal to 0. So I want to get Fn by itself, so I subtract both sides by 15, I add both sides by 98.1, and so my Fn ends up being 83.1 newtons. Okay? Alright, so there's my Fn. I am done with the first problem. So now what is the coefficient of friction? So again, I'm going to write down the equation, the only equation I have that I can use to solve for force of friction. So I have force of friction is equal to mu times normal force. I'm going to need frictional force. I'm also going to need normal force to solve for mu. coefficient of friction. So force of friction, again, what's key here is that it's going at a constant speed. So that means that the acceleration is 0, both vertically and horizontally. So let me put this in down here where the sum of the horizontal forces are also equal to 0, again, because acceleration is 0. So forces are balanced. That's what this is stating right here. So the horizontal forces that are acting on this, I have the applied horizontal force going to the right, and I have friction going in the opposite direction. So that's minus FF. So I'm just getting all this information from my free body diagram. And the sum of those, or when you subtract them, that's going to be equal to 0. So now, again, I have written down what I need to solve for, which is FAX, okay, in order to solve for FF. So FAX, I need to solve for, but let me go and show you the trigonometry to set this up. So FAX is adjacent to the angle 30 degrees. I know the hypotenuse, so now this is just going to be cosine. So cosine of theta is equal to adjacent, which is FAX. All that divided by the magnitude of the applied force. So I have cosine of 30, cosine of 30 degrees, and that's equal to FAX, which is my unknown. All that divided by the magnitude of 30 newtons. So again, I just go through to get FAX by itself. I multiply both sides by 30 newtons, and I end up getting 26 newtons. Alright, so I can go and plug that, well, actually, since these two are equal to each other, I can just go ahead and say that this is equal to my FF. So there's my FF of 26 newtons. That's equal to mu, my unknown, and the normal force I actually got up here to be 83.1 newtons, so I needed that anyway. So there's that. So now to get mu all by itself, you just simply divide both sides by 83.1, and my mu ends up being 0.313. That's it. So to kind of break things down here, the first thing I did to solve for normal force was, I really don't have an equation for normal force, so I'm going to look at it in terms of Newton's second law or first law where the forces are balanced, and that's what I did right here in step 1. But in order to do this, I needed to know FAY. So FAY, I did my work down here to do that. And force of gravity I needed, but that should be pretty simple by now, hopefully. So there's step 3 to get the force of gravity. And then I got my normal force for my final answer. So after that, to get my coefficient of friction, I wrote down my only equation I really have for coefficient of friction listed there. And then I saw that I needed the force of friction, but because there was acceleration is 0, I could just use this relationship, and then I saw that I needed to solve for FAX. So there's number 6, and then I just got my final answer from that. So again, a lot of steps here, but if you just write down the equation or relationships that you need, draw a free body diagram, and just kind of go from there. You see what you need, just solve for it. Again, it should not be too bad. All right. So that is the first angled force problem.